All right, my dudes. Sorry I couldn't be here with you. Today I am on a paternity leave with my son or daughter. But I don't know which one it is yet because it hasn't happened. But it's pretty exciting. Anyway, you guys are pressing on without me. And we're looking at 6.3 law of sine and cosine. Yeah? So put that in your notes at the top. And try this out. We've been working with angles and triangles and sides and using angles to find the missing side. So give this a shot briefly and try to solve the triangle. You're trying to find the missing side, so let's call it A and B. Cool? Pause me and try to figure that out. Go. So, what's the deal? Yeah, that doesn't, like, all our sine, cosine, and tangent, they only work with right triangles, right? This is not a right triangle. This is 110, this is 30, and if you do the subtraction, this cannot be 90, right? So this is not a right triangle. Like, sine of theta, right? Sine of an angle is the opposite over the hypotenuse. That only works with right triangles, right? Pythagoras, the SOHCAHTOA, he really only works with right triangles. So this, we're at a standstill, right? We can only solve right triangles, and so we better just go home and give up because this is not a right triangle. Cool? Good to see you. Bye. Just kidding, right? We can muscle through this. So the goal today is figure out how to solve non-right triangles with law of sine and law of cosine, right? This is not sin. I know it on your calculator. It says sin, sine. You can sin out of class, but in class you have to sine. Same thing. This isn't, don't call it cos. Oh, that's awful. Cosine. Cool, great, moving on. So, this was the same thing from the warm-up. Yeah, this is not a right triangle, but we're creative. We're creative folks. So what you can do is drop that was a little straighter, you could drop an altitude from one point to the other, and if you do it nicely and make this 90 and 90, oh, now you have this is a 90-degree triangle, and we can use Pythagorean, well, we can use Pythagorean theorem, we can use sine, cosine, tangent, we can use all sorts of things on that. And then same thing over here, oh, hey, look. Now we've got this, we've got two right triangles, and we can do battle, right? So that's all that law of cosine, sine, cosine, and tangent are about. So let's look at that more specifically. Yeah, we're gonna break this up into a couple different triangles. Right, this is our big triangle. We just said A plus B plus C should equal 180, and that's where we got the 40 from. And we broke these into some triangles here. Right, so we can do this. If you think about it, you could say, well, I know that if we know that this is 40, we know this triangle looks like this, right? This, right? If we extract this and look at it with our nerd goggles on, they told us that this side is 22. They told us that this angle is 40. And so we could figure out this height, h, right? You just say sine of 40 is opposite over, I know it's h, it means height in this case, not hypotenuse, is height over 22, and you could keep solving it from there and say, all right, we'll multiply by 22 and then solve for h, and h should end up being, being 14.1. Yeah, so you could probably see how to do that. So, okay, great. Height is 14.1. Fine, right? Now we've got this other triangle. Okay, all like that. And if we know that other triangle, now we can use this triangle, break it apart and say, hey, I know that this side is 14.1, and we know that this angle is 30. And you can do the same thing to find x. Right? You say, now we've got the opposite and hypotenuse, it's across from the 90. So sine of 30 is opposite 14.1 over hypotenuse, which is x, the long side. Right? And if you solve that, you end up with x is 28. And so now we have, this is 28. Right? So even though this big triangle is not a right triangle, we can break it up as such into right triangle size, bite-sized bits and solve that way, right? You could solve for this side and you could solve for this side, right? These two pieces, and that would give you this AB, and you could find that as well. Cool. So that's what we want to do. Oh, thanks. That's what we want to do. We've got to do it in like more systematic sort of way. Yeah. So we don't have to just break them up by feel like this. We want to do it more generically. We want a formula, right? That's the idea behind what this formula is doing, but we want to be able to do it without having to geometrically move this apart. So let's get our algebraic faces on, right? Algebraic time. Same sort of thing. Instead of 22 and x and numbers, same thing, but B, A's, and C's, and H's. H is for height. Okay, so same exact thing. You don't need to know where the formula comes from. I want you to know that it doesn't come from the math gods. It's just doing this same thing that we just did, but doing it with letters. So you don't have to derive it each time, but I'd like you to know that it comes from somewhere and it's not just magic, right? So if we do the same thing, we take this triangle, yeah, and we break it apart. And we say, great, here's our triangle again. And let's talk about this as angle A. We know this is side B and side H. So you can say sine of A is opposite over hypotenuse. I know this is H, we're calling it height. B is the hypotenuse because it's across from the 90-degree angle, right? So in here, sine of A is opposite over hypotenuse. So you should get H over B. Okay? Not too bad. In the same way, we can do that with this piece. I'm going to take this. Stop it. I'm going to steal this piece, and we know that there's this guy is B, this is A, this is H, and so you can say sine of B is the opposite over the hypotenuse. You'll end up with this, right? Opposite is the height, hypotenuse is the A because it's across from 90-degree angle. So we have these two pieces, right? Great. So if you take this and solve for H, this ends up, if you solve for H, you get H, let's do it in purple. You get H is really just B times sine of A, right? We just multiplied by B, multiplied by B, the B's cancel over here. And you get H is B sine of A. Let's do that on this side too. Let's solve for H over here. Multiply by A, these A's cancel, and you're left with H is A sine of B. Great, who cares? If you look at this like that, hey, H and H, those are the same. So therefore, if h and h are the same, then this and this should be equal, right? So you can turn this into, you can set the h is equal to each other. This might be too big of a step for us so far. So let's set them equal to each other so you can see it. So b sine of a should equal a sine of b. And that's the law of sines. To make it more useful, we're going to divide this side by a and divide this side by, so you have to do the same thing. So you divide this side by a. And so therefore these a's cancel out and it shows up here. Let's do the same thing on this side, but for b, divide this side by b and divide this side by b. These b's cancel out. And you're left with sine of a over a, right? Sine of angle a over side a equals sine of angle b over side b. And another way to look at that is this. Ping. This is the law of sines. And we'll look at how to use that in a second. So you can write that down or else it'll be in the next slide. Okay, so we've derived the law of sines. It's like it's sine of a over a equals sine of b over b. This is a flipped over version of it. It does not matter which way you do it. Let's paste this in here just so we don't get too confused. It's either way. I mean, it's just a ratio proportion. Yeah. So there's your law of sines. So sine of angle A over side A equals sine of angle B over side B. Let's try to use that. Yeah. So that means that this is just this is redundant actually. That means that you can take angle A, right? So if you took the sine of this, sine of angle A, and you divide it by the side across from angle A is side A, always, right? So if you divide by side A, you'll get the same ratio as if you take angle B, you take the sine of it, not the actual angle, but like the funky decimal associated with it, right? And you divide by the side across from it, which is called side B. Those are going to have the same ratio. Okay, so we're going to try it with this practice question, which is on this page, on the next page. Let's try it here. Let's get rid of some of these things and give it a shot here, just so we can be confident in it. Okay, so let's blow this up a little bit. We're trying to find FG, and FG is a side, right? So let's call it this side. So we can say that there's a relationship between the angle and the side across from it and any other angle and side across from that. So really, you can say sine of this angle, which is 39, so sine of 39, if you divide by the side across from it, which is 40, you'll get the same ratio as if you do any other angle. So here we're going to go sine of 32, sine of any other angle, 32, divided by the length across from it. And this one, I don't know. Call it f of g, call it x, let's call it x. And now we got to fight, right? Which is great, because you can say, I know that this divided by that equals that divided by that. This is a proportion. Many ways to solve it. I like to solve it like this. Cross product property, and so x times the sine of 39 should equal 40 times the sine of 32. The signs will be funky decimals, and then you'll just have to clean them up a little bit from there. So I'm going to grab my calculator. You grab yours and see if you can clean this up before I can. but I think I can do it faster than you. And I'm even handicapped by my... Make sure your calculator is in, right, hit the mode key. Make sure it's in degrees. Radians, you want it on degrees, or else you get messed up numbers. So sine of 39. This gives me x times 0.629. And 40 times the sine of 32 gives me 21.19. And then to get this x by itself, we're going to have to divide both sides by 0.629. Divide by 0.629. Sorry, this is getting lengthy, but x ends up as, divided by 0.629, 33.69. Let's call it 33.7. Take a look at that, right? Is that way out of the question? Nah, this is 40. This is going to be around 40 as well because these angles are similar. So these sides should be similar. Cool? All right, take that idea, and you're going to try it on in a second. You're going to use law of sines if you're given two angles and any side length, or two side lengths and any angle that's not between them. So try that on these. Right? I guess we already did this one. Yeah, that was, yay, 33.7. So you can see that nice setup for you. Try it on 2 and try it on 3. Cool? All right, here's 2. We're going to do the same thing. We're going to say, all right, I know that the, let's get rid of this one so it's not in the way. I know that the sine of any angle divided by its opposite side, right? So sine of p over its opposite side, RQ, QR, should be the same ratio as the sine of any other angle divided by its opposite side, right? So we've got the red part here, the green part here, and let's try to fill in the pieces that we do know. Try to move them over here, nice and sneaky. So it doesn't matter what you put first, you're just setting up a proportion. So here's sine of 51, that's our red piece. Sine of 51 is this, right? It's not 51 itself, it's the sine of 51, and this is the opposite side, 8, right? And same thing here. I'm looking for PR. Here's PR, so I know that I'm going to have to include the angle across from it. And that one, I don't know what it is. It's Q, so I'm going to put sine of Q in. Oh, sorry, vice versa. I know that Q is what I'm looking for, so I need to take the side across from it. So here's the 6, and that'll help me find the angle across from it. Right? So that's really nice because I know sine of 51, I can calculate that. I know 8, I know 6. The only thing we're missing is sine of Q. So to get sine of Q by itself, we would multiply both sides by 6. You'd say times 6, times 6. These cancel. You see this up in the numerator because it's like multiplying 6 over 1, and you multiply everything on top and everything on bottom. Don't get caught up in your fractions. Right? So 6 sine of 51 and 1 times 8, that's this. Great, so you crunch that, and you end up with, here, I'm just going to do it real quick. So 6 times sine of 51 all over 8. So I got 0.58. Great, and that's this, right? Now, it's not that. It's the sine of that, right? That's the sine of Q. So take that one last step, and if you want to find Q, you have to take the inverse sine now, right? I have to undo sine, so inverse sine of 0.58. So jam that through your calculator, say inverse sine of the answer, and I got 35.6 degrees, which is a more likely angle than 0.5. Look at your number and analyze it. Right? So I think that's what's under here. Yeah, 36-ish. Great. So there's a sort of a more formulaic way to do it. Neat. So if you haven't, you can try it with this one, and let's set it up together. What are we trying to find on this one? Move my face. XZ. Oh, we're trying to find XZ. Right? It said find this. Okay, no problem. I can do that. If we're trying to find XZ, I'm just going to set up this proportion again. Here, let me drag that out so we see it. You ever think you're... Yeah. Never knew my face got in the way so much. So we're trying to find XZ, which is this. So I know that I'm looking for XZ. And so I'm going to use the sine of the angle across from it. So I know that sine of 110 over xz should be the same proportion as any other angle over the sine of its the side across from it. Now, oh, wait a second. That's the problem, right? I don't know this angle. And I don't know this angle. There's a problem here because I don't know either of these. If these were the same number, we could say that 80, whatever was left over, like I know A plus B plus C, I know those all have to add up to 180. I know that we have 110 here, so I know that this plus this should be, 70. 70. But I can't say that this is 35 and this is 35 because these aren't the same length, so therefore it's not an isosceles triangle. So we're stuck in the water. We can say, right, sine of z over 35. But now there's two things that I don't know, z and xz. So it's a dirty trick. You can't do this one using the law of sines. We need something better, right? Okay, and that's where we're going with law of cosines. Law of cosines is like your last ditch attempt. It's like it'll work all the time, but it's the ugliest. So try Pythagorean theorem to find answers. Try law of sines, and if none of that works, law of cosines it is. And so here we go, brace yourself, it's law of cosines.